The history of Project 1603 submarines began in 1976, when the first prototype submarine, designated PLB 7601 and named Bentos 300, was launched. The abbreviation PLB stands for Podvodnaya Laboratoria Bukosamaya, Towed Underwater Laboratory, but this dry name reflects only the basic concept of the project. In fact, the engineers faced a more ambitious task: to create a universal underwater research vehicle capable of performing a wide range of tasks in the harshest and most inaccessible conditions. The Bentos 300 project was developed by a team of engineers from the Leningrad Institute, Gidropriber, under the leadership of Chief Designer Mikhailov. The initiative came from the USSR Ministry of Fisheries, which was interested in studying deep-sea fauna and expanding the boundaries of underwater research in areas previously inaccessible to traditional methods. The word "towed" in the name meant that the submarine was delivered to the dive site by a carrier ship. However, after the tow ropes were detached, the vehicle became completely autonomous. It could move both on the surface and at depth. The main engineering know-how was that, at the dive site, the device descended to the seabed and turned into a stationary scientific platform. The lower part of the sturdy hull contained special hydraulic supports, a kind of legs, on which the underwater laboratory rested, ensuring stability on the ground. For additional fixation on the bottom, 3 anchors were dropped, increasing the reliability of the fastening. If circumstances or the research program required it, the device could change its location and move to another place. To fulfill its main task, working on the seabed and conducting full-fledged research, the underwater laboratory needed its own power plant. That is why the submarine was equipped with a small electric motor that provided independent propulsion. The electric motor allowed it to reach speeds of up to 1.5 knots underwater, which was sufficient for maneuvering in the research area. In addition, there was a propeller motor in the front part of the lower hull, which acted as a steering device, ensuring precise course correction and positioning of the device on the seabed. The working depth was 300 meters, and the maximum depth was 400 meters, which made the Bentos 300 a very effective tool for research within the continental shelf and beyond. The submarine's autonomy in terms of habitability and resource reserves was 12 days, but with strict economy and optimization of resources, the crew could stay on board for up to 2 weeks, performing their assigned tasks. In terms of design, the Bentos 300 inherited many elements from classic submarines: a strong and lightweight hull, a ballast tank system with high-pressure air supply for surfacing, and a multi-compartment modular architecture. The sturdy cylindrical hull was divided into 3 main compartments. The first, the bow compartment, had a 2-tier layout. The upper part housed the central control station, as well as a laboratory with analytical and measuring equipment, including chemical analysis instruments, navigation modules, and communications equipment. The lower tier of the bow compartment was a visual observation post, which included both a technical compartment and a so-called observation chamber. This panoramic chamber was located at the very base of the hull, practically at ground level. Through portholes arranged in a circle and with the help of powerful external spotlights, the operator could visually observe the seabed and its inhabitants in conditions of complete darkness and increased pressure. In addition, this compartment housed various external instruments that could be extended outside through special sealed ports. These devices included salinometers, thermometers, instruments for measuring water turbidity and density, as well as samplers that allowed water or soil samples to be taken without leaving the vessel. The middle compartment of the Bentos 300 underwater laboratory was reserved for the wardroom, which served as living quarters, a recreation area, and a dining area for the crew. Despite the limited space, there were tables, seats, lockers for personal belongings, and sleeping quarters designed for alternating shifts. A large battery was located under the floor of this compartment, which provided energy to the entire onboard system of the submarine in autonomous mode. The functioning of the entire vessel, including lighting, ventilation, navigation systems, and scientific equipment, depended directly on the serviceability and charge of this battery. The aft compartment served several functions at once. It housed the engine room with the power distribution system, a galley for cooking, a toilet, rooms for the diesel generator, and a full-fledged diving complex. The galley was as compact as possible, but functional, with a stove, sink, microwave, and storage system. The toilet was airtight, with forced ventilation and a filtration system. The diesel generator was used as a backup power source. It could charge the batteries and power the submarine's electrical system in an emergency or when it was impossible to replenish energy from an external source. However, it was not designed to operate underwater. It could only be started when the submarine was on the surface or when it was near an escort vessel. This was due to limited fuel supplies and the need to discharge exhaust gases. Under normal conditions, the accompanying tugboat was entirely responsible for recharging batteries, refilling compressed air cylinders, and replenishing drinking water and food supplies. This ship not only towed the submarine to the dive site, but also remained nearby throughout the underwater operations, maintaining communication, control, and ensuring safety. One of the key features of the stern compartment was an airlock chamber specially designed for divers to exit. It had a vertical shaft, sealed at the bottom by a hatch, and allowed divers to descend to a depth of up to 100 meters. The airlock was designed for 2 people, who could enter or leave the boat at the same time. Inside the chamber, there were pressure compensation systems and water drainage pumps that ensured safety when moving between the external environment and the internal space of the vessel. The high-pressure air needed for diving operations and life support systems was stored in cylinders located above the submarine's sturdy hull, under the upper deck. The upper deck also housed the conning tower, which served as a navigation post during surface travel, and a floating rescue chamber was located in the bow. This chamber was designed to evacuate the entire crew of up to 12 people in the event of an accident or unforeseen situation. It had a sealed design, was equipped with portholes, and could be used both as an emergency capsule and as an additional space for scientific observations and visual monitoring of the underwater environment. Later, a decision was made to build another, improved version of the Project 1603 underwater laboratory. Work on the new submarine was completed in 1983. It was given the index PLB 8302 and the unofficial name Bentos II. This modernized version differed significantly from the first model, both in appearance and in technical features. The main innovation was the introduction of a new hydrological complex called Gradient, which allowed for more accurate research of seawater, its temperature, salinity, density, and other parameters in real time. Most of the complex's components were installed inside the conning tower, which increased its height. This required redesigning the conning tower and raising its center of gravity, which in turn necessitated strengthening the ballast system to ensure stability at depth. A special buoy equipped with sensors and a telemetry system was also installed on the Bentos II. It was connected to the submarine by a rope and cable, moved by a winch, and allowed for dynamic observation of the underwater environment, including the surface. In addition, a new generation sonar was introduced into the modernized device, expanding the capabilities of navigation and seabed exploration in conditions of limited visibility or murky water. Although there were few external changes, these improvements significantly increased the efficiency, safety, and research potential of the submarine. Both boats, Bentos I and Bentos II, were officially handed over to the customer, the State Scientific and Production Enterprise Marine Technologies, right on time, in accordance with the delivery schedule. Initial tests demonstrated the high reliability of the vessels. Not a single incident was recorded, which allowed both vessels to be put into full operation immediately without the need for further modifications. The submarines were actively used and, to put it mildly, did not sit idle. They regularly went out to sea and spent long periods of time at underwater research sites. 2 whaling ships, the Gordy and the Divney, were specially allocated to tow them. These vessels were converted for scientific missions and equipped with everything necessary to service underwater laboratories, store supplies and fuel, and accommodate technical personnel. It was with their help that the Bentos were delivered to the most remote areas of the sea and ocean. The crews of the Project 1603 underwater laboratories, in particular the Bentos-type submarines, consisted of highly qualified specialists, experienced hydrots, divers, scientific equipment operators, engineers, and a doctor. Each crew member underwent special training, as the working conditions were not only difficult but also potentially dangerous. Working underwater at depths of up to 300 to 400 meters required not only technical training but also psychological resilience. The submarines themselves were used to perform a whole range of tasks, the main ones being long-term stationary underwater observations of changes in the hydrological and biological environment, including temperature, salinity, current speed, and fauna, conducting scientific research using a variety of equipment, both on board and portable, and collecting samples for analysis: water, soil, algae, plankton, with divers from boats at depths of up to 60 meters. Of particular importance was the work to assess algae and mussel stocks in the Black and Azov Seas, a task that had both scientific and practical value, for example, for the food and pharmaceutical industries. In addition, with the help of the bentos, sunken ships, underwater objects, and other antiquities were discovered and further studied by third parties, including fragments of ancient ships, amphorae, metal structures, anchors, and mechanisms. In these missions, underwater laboratories worked at the intersection of science and archaeology. There were also dangerous situations. As one of the hydronauts, Anatoly Tavrichesky, recalled, during one of the dives, the Bentos 300 boat almost fell victim to an accident. It was almost overturned by a trawl being dragged by a fishing trawler. According to the regulations, the tugboat accompanying the submarine was supposed to remain in the area of its dive, sending radio signals and flags to warn approaching vessels of underwater operations. However, on that occasion, the watch on duty on the ship simply missed the approaching trawler. As a result, the boat was severely rocked, the external elements of the superstructure were damaged, and the paint was partially scraped off the wheelhouse. Fortunately, the hull withstood the impact, and serious consequences were avoided. Bentos-class submarines also interacted with the Soviet Navy from time to time. They were involved in military experiments and technical surveys, conducted underwater surveys of cables and pipelines, and participated in checking the condition of the seabed in areas of proposed construction. Their unique capabilities allowed them to perform tasks that were inaccessible to both conventional divers and large submarines. However, with the collapse of the Soviet Union, the situation changed dramatically. The underwater laboratories were left without funding, the maintenance staff was reduced, and the boats themselves, such as the Bentos 300 and Bentos 2, were moored at the docks, where they began to slowly rust. Soon, for various reasons, the Project 1603 underwater laboratories ceased to exist. Bentos 2, PLB 8302, sank as a result of a storm. While being towed in the Novorossiysk area, the vessel broke away from the ship, and the heavy submarine, deprived of control, sank to the bottom. At first, there were no plans to raise it. It lay at a great depth, and a rescue operation seemed too costly. However, at some point, it became clear that the sunken hull was interfering with underwater work and infrastructure construction. The decision was made to raise it. The vessel was pulled from the bottom and, after assessing the overall condition of the structure, sent for dismantling. Valuable metal elements were sent for recycling. Thus ended the story of the most technologically advanced submarine of this unique project. As for the Bentos 300, PLB 7601, its fate was somewhat different. The vessel had been moored at a pier in one of the Black Sea ports for a long time, but at some point it sank right at the pier in shallow water. According to eyewitnesses, the cause was a combination of technical malfunction and negligence in storage. However, it was deemed possible to save this submarine. It was successfully raised, and repair work is currently underway at a restoration facility. After restoration, the hull of the Bentos 300 is planned to be converted into a stationary museum, displaying the internal equipment, portholes, airlock chamber, and all scientific instruments. The exhibition will be dedicated to underwater research and marine technology during the Soviet era. It will be the first museum in Russia based on board a Rayal Research submarine laboratory. After the closure of the Bentos project and the decommissioning of both submarines, similar vessels were not further developed in the USSR and later in Russia. During service, it became clear that the use of large manned underwater laboratories was extremely expensive and logistically complex. The need for a tugboat, the vulnerability of the design, maintenance difficulties, and dependence on weather conditions made the project less effective than alternatives. Against the backdrop of rapid technological progress, compact unmanned deep-sea vehicles with remote control began to gain popularity. Such devices were much cheaper to operate, did not require the creation of living conditions for the crew, and could dive to depths inaccessible to the Bentos. It was these vehicles that gradually replaced manned underwater laboratories in the field of scientific research. Nevertheless, the ideas behind the Bentos found a kind of continuation. Closely related to this project is the lesser-known but ambitious Soviet tourist and research vehicle called OSF, Habitable Medium Fleet Vehicle, AST Picard. It was conceived as a unique hybrid between a scientific platform and a tourist bathyscaphe, the first domestic project of its kind for a research and tourist manned vehicle. The apparatus was supposed to not only conduct scientific research, but also give civilians, including foreign guests, the opportunity to dive into the depths of the sea and observe the underwater world in real time. Although the project remained in the prototype stage, it is considered the forerunner of many modern concepts of private bathyscaphes and deep-sea tours. Thus ended, but did not completely disappear, the era of Soviet-manned underwater laboratories. Although it gave way to new technologies, it left an important mark on the history of marine research.